Hello everyone, and welcome to Lily's general tour of a CubeSat simulator. This is a simulator that I recently finished building, and it is an AMSAT CubeSat simulator, so it works in the amateur radio 440 band, and it's a training tool to help people learn how a satellite works, either by building a simulated one or borrowing and using one for educational reasons. So I'll start with this CubeSat simulator from the bottom up. So this is the bottom solar panel. This is the negative Z side. And underneath this panel you can see the Raspberry Pi right there, the green board with the big raspberry on it. That is the brains of this. It has a CubeSat simulator image that's on an SD card. That's basically the brain of this Raspberry Pi. The kind of golden orange looking cable is the cable that goes to the Raspberry Pi camera, which we'll get into later when talking about slow scan TV. The little blue boards are voltage and current sensor boards for the power supply, the batteries, and all these solar panels. And there are 8 of them, and there are 4 on each side of this bottom printed circuit board, which is the white board there underneath everything. That's the AMSAT board. These boards were sold by AMSAT, but all the other parts I had to source myself, and that can be difficult these days. So I'll put this back on, and if we turn this over, this is the side of the CubeSat that's got all the switches and blinky lights, and right now everything's off because the remove before flight tag is in the jack. But if I pull that, the Raspberry Pi will start up, and in a minute you'll actually see all those lights start to come to life. So if I take this side off, you can see the stacked GPIO headers, and the Raspberry Pi is plugged into the very bottom, and those headers go all the way up past the battery board, which is the center board, all the way up to the payload board at the top, and that allows the payload board to communicate with the Raspberry Pi. The Morse code you hear is actually the CubeSat simulator sending my call sign saying that this thing is now transmitting, and the blue light is the transmit light, the green light is the power light. And the curly connector there with the SMA at the bottom, that's the antenna connector. It goes all the way up from the bottom main board all the way up to the little antenna that transmits. So I'll see if I can get this back on here. And there's the data starting to transmit. And then on the side here, you can see the little blue sensors there in the middle. They're kind of hard to see. My phone doesn't want to focus very well. But those are the voltage and current sensors. There's 4 of them on that side of the board. I chose to plug them into sockets, so if there was any issue with them, they could be fairly easily replaced. And all the black and red wires are power cables going from these solar panels to the sockets for the voltage current sensors. Here on the top is the payload board, and the little red chip in there is an Arduino. That's a SparkFun Pro Micro, and that's the microcontroller. That's basically the brain of the payload board, and you can load that up with code for different experiments. And right now the code that's on it is the code that's basically reading telemetry from these two sensors. There's an environment sensor and a gyroscope, and also reading from the Raspberry Pi, talking to the and basically telling the Raspberry Pi what's coming through these two sensors here. There's a lot of other pads there. You can add experiments to this board. That will hopefully be a future project. So that's the top of the top board in the CubeSat simulator. The middle board basically has 3 AA rechargeable cells, and the bottom board has a voltage converter that converts that 4.5 volts to 5 volts, which is what the Raspberry Pi needs to function. Let me turn this into the light so you can see the Pi camera, and that in SSTV mode, that camera will take a picture and transmit it every couple minutes. So there's a lot going on here. This is an actual typical way that CubeSats are constructed, with a frame. It's usually, in real life, it's a metal frame, and there's a stack of circuit boards on the inside, each with a different function. So this is actually a pretty typical way that a CubeSat is constructed in real life. So this is a good beginning project for someone like me who would like to actually design and build satellites in the future. So thank you for watching.